Hello dear students, welcome back to your math classes. How are you all? I hope you all are healthy and doing well. So students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 14, which is visualizing solid shape. So till now we still learnt about the 2D shape, for example square, rectangle. But in this chapter we are going to visualize solid shape. But what does mean by solid shape? So this 3D shapes you have, for example cuboid, cube, cylinder, these are the 3D shapes. So now we are going to learn the difference between 2D and 3D and how can we visualize the 3D shapes and what are the things we have which is not present in your 2D shape but in 3D have. So introduction, in the previous class we have read about some solid shape and various terms like face, edge and vertex. So we already know about face, edge and vertex, right? So associated with each of these shapes, here you shall briefly revise these concepts and learn more about solid shapes. Now we associate another term with the shape and figures you have studied. The term is dimension. When we say 2D, D stands for dimension. When we say 3D, D stands for dimension. So the word dimension derived from Latin word meaning measure out. In common usage, a dimension is a measurable aspect of an object. Dimension of an object is the number of parameters required to define the characteristics of an object. The most commonly used dimension give the measure describing the length, breadth and height. You have read about a basic geometric concept that has zero dimension point. Yes, we already learnt about point, in which we see the definition of point that it has no length, no breadth, no height and no dimension. So when we have these three things, length, breadth and height, it means it has some dimensions. Okay, so now you have also read about shapes having length only. These are these are lines and line segments. They are called one dimensional figures. You have learnt about figures having length and breadth. These are called 2D, two dimensional figures, for example square and rectangle. When we have three things, length, breadth and height, that figure it's called three-dimensional figure or solid figure. And the examples we have cube, cuboid, cylinder, right? So we shall write 2D in short form, two-dimensional shapes, and 3D in short form, three-dimensional shapes, right? So face, edges and vertex. So we are going to learn about in detail about the face, edge and vertex. But before that, you have to do a recapitulation for the previous concept you have learnt about these three things. So you have read about faces, edges and vertex of various 3D figures in your previous class. We go through in brief faces, edges and vertex of these 3D shapes. Cuboid. A cuboid has 6 rectangular faces, 12 edges and 8 vertices. So how can you learn? First of all, we discussed like this: face, then edge and then vertex. 6, 12 and 8. So these are the numbers we have in cuboid: 6 rectangular faces, 12 edges and 8 vertices. Same we have cube. So 6 square faces, 12 edges and 8 vertices. In cylinder we have only 2 circular faces, 1 curved face and 2 curved face. So 3 होने चाहिए थे. A cylinder has 2 circular faces, 1 curved face and 1 curved edge. Okay. Now cone. A cone has 1 curved face, 1 flat face and 1 curved edge and 1 vertex. Only 1 face. Okay. 1 curved face, 1 flat face, means total 2 face we have. 1 curved edge and 1 vertex. Next we have pyramid. This is your pyramid. A triangular pyramid has 4 faces, 6 edges and 4 vertices. 4 faces. So in this figure what you see, 4 faces, 1, 2, 3 and 4. By doing this 1, 2, 3, and when you have a 3D shape, so you can see the back side of it as well. So we have 4 faces. Now 6 edges we have and 4 vertices. A square pyramid has 5 faces, 8 edges and 5 vertices. This is your rectangular triangular pyramid. And when we have our square pyramid, so the difference is we have 5 faces, 8 edges and 5 vertices. Now next we have sphere. A sphere has a curved face. It has no vertex and no edge. So sphere has only one face. That's it. One curved face, no vertex and no edge. You may know that the flat faces of 3D shapes are 2D shape. For example, the 6 faces of cube are squares. The 4 faces of triangular pyramid are triangle. A square pyramid has 4 faces which are triangle and 1 face which is square. So what we understood here that the 3D shapes include 2D shapes as well. Now, nets for building 3D shapes. Now we are going to discuss about the nets we have to use for building our 3D shape. So now we are going to learn about the nets for building 3D shapes. So we say how we need and what are the nets we have to make our 3D shape. You must have seen that most boxes are cubes or cuboids. They are cut from flat pieces of cardboard and folded into the shape of boxes. To understand this, take a cardboard box and cut the edges of the box as shown in figure B. So this is your activity which you have to perform. By performing this activity, what you understand here that how we have a flat surface and we can say a net figure we have to make a 3D shape. If you've seen your matchbox, right? So the matchbox is also made of your flat surface and we just cut down the edges of it, or by connecting the edges together we have our 3D shape. So the net of a 3D shape is the shape that can be cut out of flat pieces of paper and folded to make a 3D shape. And the sweet boxes we also have which we made for which we have net shapes and further we fold it so we have a 3D shape as well. So drawing a net of the faces of the solid figure simplifies the process of making a solid figure from a piece of cardboard. The net comprises of different plane shapes, namely triangle, rectangle, square, circles, etc. Net pattern. So now we are going to see the net patterns we have for different 3D shape. This is the net pattern for we have for cuboid. So you have to give a look at two. So you have to give a look here. Next we have net pattern for cube. This is for cube. This is for cylinder. This one for cone and this one for triangular pyramid where we have 4 triangle, and this is your square pyramid, 1 square and 4 triangle we have, and this is your triangular prism where we have 3 rectangular faces, or we can say it could be your square and 2 triangle we have. So now we have our exercise 14.1, filling the blanks. A cuboid has dash faces, 6 faces. Two adjacent faces of a cube meet in a line segment. Call it what we called it. You have to answer it. Okay. Now a triangular pyramid has dash triangular faces. How many triangular faces we have in a triangular prism? Yes, you're right. If you have any doubt, so you can see here. We have triangular prism. So how many faces we have? Right? You can write your answer 2. A cone has 1 dash face and 1 dash face. So you have to answer it. I already explained you each and everything in your concept. You have to go through and try to fill all the blanks we have. Now match the nets with appropriate solid. So we already discussed this as well. So now conclude which is your shape for and what is your pyramid. Okay, so now conclude that what are the nets we have for our 3D shapes and matched it. So first of all, we have this. So by seeing this, what you understand here? It is your cuboid. Okay, this is your cube. Now we have this, and by seeing this, we can easily understand this is for cone. So similarly, you have to match your net figures with your 3D figures. Okay. Now we are going forward to our question number 3. Identify the nets which can be used to make cubes. So now you have to identify which one figure is suitable for to make a cube. So before that, we have to go through this. You see here, this figure we are using for cube because in this we have all square shapes and this is our net figure. So according to this, you have to conclude this. If you have any doubt, what can you do? You can also go through your previous concept where we discussed the net figures. But according to me, the D part is correct. And further, you have to classify, am I wrong or am I right? Okay. There are possibility chance also that I am wrong. But you have to classify that is this correct answer or not. So this is your task. Okay. Identify the nets which can be used to make a tetrahedron. So now you have to make a tetrahedron. Tetrahedron we generally say triangular prism, right? So you have to select your correct net diagram. The number on the opposite faces of dies add up to 7. Can the following be a net for a die? Explain your answer. 1 plus 6, 7. 2 plus 3 is 5. So how could it be possible while we making it? So we have 1 here. So 6 plus and 4 plus 5. So now what we have to do here, this is your question number 4. Find the Identify the nets which can be used to make a tetrahedron. In tetrahedron means your triangular pyramid, right? Triangular prism. So in figure A, it's possible, and figure B as well. This is possible because when you make it by folding it, so what you observe that one, this triangle is your base and other three are in your opposite. So accordingly, you have to describe your answer in part A also. There is advice from my side that you can make a net diagram for this, and further you can conclude your own, is this possible or not. The number on the opposite faces of dice add up to 7. Can the following be a net for a die? Explain your answer. Yes, this is possible because when we fold it, what we see that it is a cube net diagram, right? And in cube, what we conclude that the opposite two numbers sum should be equal to 7. So when we add 6 plus 1, so it is equal to 7. 5 plus 2 is equal to 7. So accordingly, we can answer this question. Yes, this is your reason for this. Now draw the net for a cuboid whose dimensions are 4 centimeter, 3 centimeter and 5 centimeter. So this is very easy for you. You just have to make three faces with these three dimensions: length, breadth and height. And further, when you fold it, you have your cuboid. Now the following diagram show the nets to make dice. Write down the number of doors that should be there in place X, Y and Z. So when we try to make a dice, what we have to keep in mind that the sum should be equal to 7. So for example, if we have 6, 5 plus 1, it's 6, and 6 plus 1 is equal to 7. So we have to make a dot here. So accordingly, you have to fill rest of the two figures, rest of the two values you have in the form in Z and Y, by concluding that their sum should be equal to 7. Now drawing cubes and cuboids. Two-dimensional drawings on a flat surface can be made to convey an illusion of 3D reality. A three-dimensional object may look different when we view it from different angles. In this section, you shall learn two types of drawings of cubes and cuboid, oblique sketches and isometric sketches. So in this category, in this section, we are going to learn about the oblique sketches and isometric sketches. This method of pictorial drawing is based on the procedure of placing the object with one face parallel to the frontal plane and placing the other two faces on oblique planes. This is very easy. We already do in our smaller classes. What we do when we have to make a cuboid, okay, first we have to make a rectangle, then we have to make another rectangle, and just we have to connect their vertices together. So what we see here, that this is your 3D diagram of cuboid. That's it. So this is the whole thing we are going to learn here. Draw an oblique sketch of a cuboid whose dimension is 3 centimeter, 2 centimeter and 2 centimeter. So what we consider here, 1, 2, 3, 3 centimeter, 2 centimeter and 2 centimeter. So draw a rectangle of front view measuring 3 centimeter and 2 centimeter, 3 and 2. Further draw oblique line segment at 45-degree angle to the horizontal starting at the intersection of the vertical and horizontal base lines. These line segments are of the same length. So one another should be same. So further what we conclude here, here is your another parallel rectangle to it. Now you just have to connect the lines like this, and further you have your cuboid here. That's it. Draw an oblique sketch of cube of size 4 centimeter, 4 centimeter, 4 centimeter. So here is your square 4 centimeter, 4 centimeter. Further you can make it like this as well, or you can further make a square 4 centimeter, 4 centimeter like this, and you just have to connect the vertices of it. Now we have our isometric sketches. So isometric sketches, the term isometric comes from the Greek for equal measure. Isometric sketches are made as if you were looking down diagonal of a cube or cuboid. In an isometric drawing, the object's vertical lines are drawn vertical and horizontal lines in the width and the depth plane are shown 30 degree to the horizontal. When drawn under these guidelines, the lines are parallel to these three axes are at their true scale lengths. In an isometric sketch, all faces of a cuboid appear distorted, the measurement of exact scale size. So this is your again isometric sketches. You have to make a cube with the size of 2 centimeter length, 2 centimeter breadth and 2 centimeter height. So what you have to do in this section, isometric sketches, in oblique sketches we have squares, or in this section we have dots where we have to make it. So first of all, we have to measure 2 centimeter. Draw vertical line. Okay. So 1, 2. Okay. 1 centimeter. So first of all, you have to draw 2 centimeter. Now draw oblique line segments, each measuring 2 centimeter and at 30 degree to the horizontal at the two end points of the vertical line segment. Then further you have to make your 2 centimeter line, and same for you have to connect it. Same in this, and you have to connect it. Further you have to draw in this direction 2 centimeter, and further you have to just connect them together, and here is your cube with 2 centimeter, 2 centimeter and 2 centimeter. Now we have to make a cuboid 3 centimeter, 2 centimeter and 2 centimeter. So this is your 2 centimeter line, and then we have 3 centimeter, 1, 2, 3. Okay. Now same we have to proceed here with 2 centimeter and 2 centimeter, because in cuboid we have rectangular faces, right? So accordingly when you made it, so this is your 3 centimeter and this 2 centimeter and 2 centimeter. Okay. So now we have our exercise 14.2. Make an oblique sketch of a cube size of 3 centimeter, 3 centimeter, 3 centimeter. So you have to first make a square with these measurement, and accordingly one more square with this measurement, and you just have to connect them together, and you have your oblique sketch for a cube. And same procedure for you have to done for the cuboid. Make isometric sketches for each of the following. Cube edge of 2.5 centimeter. So in isometric section, what we have to do, you have these kind of points, and according to this you have to measure your 2.5 centimeter square. Okay. In cube we have square faces, and square we have all four sides equal to each other. So cube, your two squares basically you have to make 2.5 centimeter. For example, this is your 2.5 centimeter. So you have to make here 2.5 centimeter, here 2.5 centimeter, same here 2.5 centimeter, 2.5 centimeter, and you just need to connect them together. And further you have your cuboid. My cuboid, it's not according to your measurement, but this kind of thing you have to draw here. Make 3 different isometric sketch of cuboid whose edge are 6 centimeter, 4 centimeter and 2 centimeter. So by displacing this, first of all you have to take 6 centimeter length, 4 centimeter breadth and 2 centimeter height. And next you have to take 6 centimeter breadth, 4 centimeter length and 2 centimeter height. And next you have to take 6 centimeter height, 4 centimeter length and 2 centimeter breadth, and you can easily make it. Make an oblique sketch for each of the solids whose isometric figures are there. So this is your cuboid, right? So you have to measure 1, 2, 3, 4, 5. It means it is 2.5, because what we observe in this, we have 1, 2, 3, 4, 5. 5, it means 2 centimeter. This is your 3 centimeter, and in cube we have only one measurement, because in square all four sides are equal to each other. So you just have to make a 3 centimeter square, and then again a 3 centimeter square, and further you have to connect their vertices like this, and this is your figure you have. So accordingly you have to take measurement for first of all you have to measure this isometric figures you have, and then accordingly you have to make oblique sketches for the following. And these are the things you have to keep in your mind while you solve this chapter. I hope so students you like this chapter, because this chapter is very easy and you understood it very well. Now I'm going to meet you in your next class. Till that, bye bye, have a good day.